Hi, I'm Ashley Scott, Executive Communications Manager here at HPE. I'm joined today by Andrew DeRocher, Principal Technologist of Sustainable Transformation, and Colin Bash, VP and HPE Labs Deputy Director. Colin, Andrew, thank you for joining us.
Yeah, thank you, Ashley. Good to see you.
Good to see you as well. So, Andrew, let's start with you.
Yeah.
So, you spend a lot of time talking to customers. What are the main challenges you're hearing right now when it comes to infrastructure growth, AI, and energy?
Yeah, for sure. What we've seen from customers is that while the age of AI has brought on an immense amount of promise for their business, it hasn't come without its challenges. We've seen the increased complexity of these workloads force teams to consider their cross-organizational collaboration, collaborating with teams that they may not be averagely working with on a day-to-day basis. And then even from there, as we go into this more advanced phase of AI, as we reach new levels of maturity, we're starting to see another concern start to creep in. It's the rising cost of energy and resources that it takes to power our AI workloads. And so with these increased cost pressures, our customers are asking themselves, how am I able to achieve the return on investment that my organizations are expecting while costs continue to rise? And even if customers are able to cut through all of those pressures, they're seeing new areas of headwinds, and that's their internal users starting to, even in some cases, reject the AI initiatives and the strategy that they have within their organizations. We've seen some studies say that as much as 41% of employees are actively admitting to saying, I'm taking a step back, I'm not engaging with my company's AI strategy.
41%?
41%.
Wow.
For a multitude of reasons, right? That could be for a fear of replacement. It could be a fear of accidental misuse. But what we've heard more and more is this fear of unintentional impact. They're hearing all these things in the media about the rising energy consumption of our AI workloads, rising resource constraints. And they're saying, hey, am I having an unintended impact where I'm not meaning to by engaging with my company's AI strategy? And so we're seeing our customers start to struggle with the fact of how do I increase my transparency into the way that I'm running these workloads to gain acceptance and gain adoption across my internal user base.
Got it. So, Colin, why is this becoming such a big issue now, and how do you see the challenge evolving?
Well, it's becoming an issue now, but it actually started well before now.
Yeah.
And in 2022, HPE and in partnership with AMD and Oak Ridge National Lab released Frontier, which was the world's first exascale system, and it's still running today. It was the most powerful system in the world when it was commissioned, and it consumed 30 megawatts. At maximum, the best that can do in terms of performance, it was going to consume about 30 megawatts of power. That was 2022. 2025, there's been a progression of supercomputers, AI supercomputers that have been deployed and commissioned since then. 2025, the most powerful is consuming 300 megawatts. So we went in 3 years from 30 megawatts to 300 megawatts.
That's a big jump.
That is an exponential jump.
Yeah.
And the curve is not flattening. It's continuing to go up. So this is going to be a problem for some time. It's going to be a challenge for some time. Now, when we think about those systems, what are they used for? They're used initially for model training, right? Where we're taking the sum total of human knowledge, all of this data, we're feeding those models, portion of that data to train them. And those models now are so big that they're trillions of parameters. So these computers are trying to figure out, all right, what's the right weight for all of those parameters so we can get an accurate model. So that could consume hundreds of megawatts over a period of months to train that model. Once those models are trained, they're then used to infer. We're actually putting them to use, right? We give them a question, a query, and they come back with an answer, and they consume energy doing that. So training was kind of the first stage. The next stage now is inference. And so we use it with chatbots. We communicate with our chatbot, and that chatbot uses these large models, consumes energy, and there's a lot of energy consumed there. But now we're moving into the age of agentic AI. So this is where we are now. And instead of humans doing these queries, agents are now doing the queries. And so instead of billions of queries, we're now moving up to significantly larger number than that, and that's going to continue to grow. So that is the challenge.
Okay.
And in the future, we need to think about, all right, how is this going to evolve? Well, it's on a curve now to be even more challenging if we don't get a handle on how to make this whole system more efficient.
Got it. So then from your perspective, staying with that, what can organizations do today to improve efficiency and get more from the capacity that they already have?
So we talk about agents, right? And these agents are able to use tools.
Okay.
They're able to evoke what we call large language models, which are these big models that are being developed.
Yes.
And it doesn't make a lot of sense to have an agent evoke a foundational large language model for a small task. And so what we can do today is think about creating smaller models from those larger models that are task specific. So if customers are thinking about agentic AI and agentic meshes, the best advice right now is make sure that the model that we're using is sized according to the resources that you want to expend.
Okay.
That could save a tremendous amount in terms of energy consumption. Now, I'm with HPE Labs, we tend to think a little bit farther out into the future.
Sure.
And so some of the things that we're working on, that's still research, but it's closer to being something that customers can get their hands on, is server consolidation. Very simple notion, right? When GPUs aren't being used to their full capacity, because workload changes throughout the day in terms of demand, we can consolidate that workload onto a smaller number of GPUs and turn off the ones that aren't being used.
Makes sense.
Seems really simple, right? But the devil's in the details when
Yes.
it comes to all of this stuff.
Yes.
And there are other things we're working on too. One thing I like to point out, which I think has always been very cool, is something that we call holistic power management, which was a program that was a collaboration between our HPC business unit and HPE Labs. And the way I like to talk about it is, imagine you had a slider bar. The customer has a slider bar going from performance on one end to energy efficiency on the other end. That user can now slide the performance dial back just a little bit, maybe 1% or even 0.5%, and achieve significant energy savings, 20% or so, because we're dialing back the GPU frequency and therefore saving energy.
Wow.
So these are the
Okay.
things that are coming near term that we think customers can think about deploying.
That's great. That's helpful. So what about you, Andrew? What, from your perspective, do you think organizations can do to improve?
Well, first off, I couldn't agree with Cullen more, right? What we've seen in some of the research that we've done is that some of the things that customers are fearful of in terms of throttling a little bit of performance, it doesn't actually have as much of a performance impact, but it does have a very significant energy efficiency impact. And so, we're encouraging customers to consider that slider that Colin talked about and see that, that performance hit isn't as drastic
as they're
they might have
worried
seen
about.
it to be,
Sure.
right.
It's almost training them then.
Exactly. And from our team's perspective, we bring our unique POV on efficiency to the table when we collaborate hand in hand with our customers. We look through the 5 levers of data efficiency. How are you storing and utilizing your data as efficiently as possible? Software efficiency, deploying software and code base that's aware of its energy and resource consumption. Resource efficiency, energy efficiency, and equipment efficiency. And those are our 5 levers that we've developed over time in the 25-year history of our practice to give our customers a unique perspective on how they can drive efficiency across their entire IT estate. Now, those concepts were developed for IT, general IT workloads, right?
Okay.
We asked ourselves, do we need a 6th lever for AI? What we found is that applies really nicely to the AI lifecycle, right? We can take those concepts of efficiency, we can take those levers of efficiency and apply them to the typical lifecycle that our customers are used to. And so from our team's perspective, I think it's important for our customers to analyze what they have, understand the current energy consumption of their estate, so they have a baseline they can look to measure down from.
Sure.
And then from there, it's optimize the resources that are existing. Like Colin said, what we often find is that utilization rates are much lower than our customers expect, and that we can look to lift those utilizations, especially in a time of such rampant cost constraints that our customers are under, and then modernize wherever possible, right? Some of our systems were not designed for AI workloads. So we need to make sure that we are, using the right tools for the job, right?
Yeah.
Deploying infrastructure and equipment to meet the demands of our modern AI enterprise.
Got it. So, Colin, with your crystal ball, if you were to look ahead, what role do you see IT playing in the broader energy ecosystem?
I think IT is going to be critical in helping us solve some of these challenges. And I'll give you one example. So we talked about agentic AI previously and agentic meshes.
Yep.
Well, liquid cooling is a really good example of this. Liquid cooling is also a way to save energy in
Sure.
these big systems. But think about liquid cooling let's go back to Frontier, because we talked about that earlier. That's a 100% liquid cooled system.
Okay.
And there are valves and pumps within that system that we can control for energy efficiency and for performance.
Mm-hmm.
Future systems are going to have much tighter control of flow rate for any particular blade in that system. Think of a blade housing CPUs and GPUs, and there are many of them in the system. What we'd like to do is have more granular control of that flow through each blade, so we're giving it the right amount of flow it needs for the amount of power it's dissipating, heat it's dissipating.
Okay.
That means we have a lot more actuators in that system.
Yeah.
We have valves everywhere. We have potentially pumps in many different places. That becomes a very interesting and challenging control problem. Well, it turns out that reinforcement learning and AI can help with that control problem. So it's two sides of the same coin, right? AI is providing a challenge for us to power and to cool, but it can also help us with managing that complexity in the future. And so that's one way IT can help. Another is through digital twins. And again, going back to Frontier, which is I guess a recurring theme today, we built, along with Oak Ridge National Lab and some consortium members, the first full-scale digital twin of a supercomputer. And a digital twin is a simulation of subsystems of a physical thing that we're interested in. That physical thing is the supercomputer. Telemetry is exchanged between the simulation, the twin, and the physical twin. And so that digital twin stays updated over time. And what they're using it for is a way to improve overall optimization of the system, energy optimization of the system, because that twin is helping us model energy consumption of the cooling infrastructure and of the IT infrastructure. And then we can combine that with AI to help with optimizing the whole thing. So there's a huge role for IT to play in this. There has to be a role for us to make progress.
Great. Thank you. All right, Andrew, bring this to life for us. Can you share one way customers are putting this into practice today?
Yeah, for sure. Well, over time, what we've seen is that our general IT practitioners, our IT decision makers, our IT operators have kind of assumed that energy would always be there, right? And as we're in a time of rising energy costs and in some regions, energy constraints, dealing with the energy variable is kind of a new concept for them, right? The facility side folks are very aware of this, but the IT folks may not have been in the past. But one industry that we can look to that's been doing this for a long time and that has been considering their efficiency for a long time, just based on the nature of their business, is our friends over in the cruise line industry, right? All of their power has to be generated on their ships, right? Once they're underway, they need a massive amount of power from their engines to move the ship through the water. And then whatever energy is left is what's left for the ship, right? So any kilowatt of energy that they need for their IT systems, whether they be AI workloads, whether they be guest-facing IT workloads, whether they be internal IT workloads, every kilowatt of energy that they need to power the IT stack that's on that ship is taken away from other guest services. It's a movie they can't show on the cruise deck. It's a load of laundry they can't do to have clean sheets in the room.
Literally pulling away from their business.
Truly. And so they've had to be energy efficient by design in their IT infrastructure, just by the nature of their business. And so we can look to them for inspiration as we enter kind of this brave new world now.
Oh, great.
Yeah, good example.
Yeah, that's great. All right, so a little speed round to close things off. In 30 seconds or less, Colin, we'll start with you. What are you urging customers to be optimistic or excited about in this space?
We are entering an entirely new phase of how we think about technology with AI. It's exciting. And it's exciting because the possibilities are in some sense endless. You know, there are those who think that agents will be everywhere. Okay, fine. Maybe that's true, but how we think about deploying them, how we think about interacting with this new technology, for me, is exciting, and it should be exciting to all of our customers. I know it is. They're trying to figure out, how do we utilize this in a way that makes the most sense. And so creativity is endless for humans. So how are we going to take this new technology, and for our customers, how are you all going to use it to improve your business, improve their business? That's what I'm looking forward to, interacting with them so that we can bring this technology forward in a way that's responsible,
Sure.
and in a way that's sustainable,
Right.
for the future as well, because we don't want to burn out in the first few years.
Yeah,
Right?
and
This
you
is a new revolution for us. Let's make sure that it's sustainable, and that we're getting as much value out of it as we possibly can.
That's great. And you want the 41% number to go lower that Andrew mentioned earlier. So,
Yeah, exactly.
all right, Andrew, what about you? 30 seconds or less. What are you urging
30
customers to
seconds.
be optimistic about?
Discover 2036. I hope that we're not having this energy efficiency conversation. I really am optimistic about the fact that we're starting to see organizations like our friends over in the cruise line industry, and even our higher academic institutions, start to train some of the new talent that's coming into the space on energy efficiency in their education. I hope that this is going to be something that's inherent to the way that we operate as IT practitioners, that we are efficient by design, and that this is not even a conversation that we're having because it's just a basic way that we operate.
Got it. Well, thank you, Andrew. Thank you, Colin.
Thank you.
Definitely looking forward to seeing how this evolves. And in 10 years, we can check back in.
Let's
Thank
do it.
Thank you.
Thank you. Thank you all for joining us today.